Hi there. We looked today in class at the derivatives of inverse functions, and so I've selected here three inverse trig functions to demonstrate their derivatives and some of the thought processes behind it. Okay, the first one is number 46, which is f of x equals arctan of square root of x. Okay, the derivative of arctangent x is u prime over 1 plus u squared, and u is the function within arctangent, right? So our derivative here, we have arctangent of x to the 1/2. Okay, so we're going to do u prime first. So we're taking the derivative of, I'm actually going to go ahead and rewrite this so we can see it. So u prime first, we're taking the derivative of x to the 1/2. So I'm going to go ahead and bring down that exponent and subtract 1 from the exponent. Okay, that's my u prime, derivative of x to the 1/2. Okay, this is all over 1 plus my u squared. So my u in this case is x to the 1/2 squared. Okay, if we were to clean this up a little bit, we'd have 1 over 2 root x. That's what this is, right? 2 root x in the denominator. All over 1 plus the square root of x squared, which is just x. Okay? And then if they asked us to get rid of that extra denominator, we'd multiply every term by that denominator. Because that then would allow that 2 root x to cancel. So we'd have 1 over 2 root x plus 2x to the 3/2. And they could potentially, leave the 2 root x factored out over here. That might be the other potential spot where they left it. Is rather than multiply the 2 root x to both pieces, they might just leave it outside the 1 plus x altogether. Might leave the 2 root x out here, and then just leave it as 1 plus x. Either one of these would be potential sources. Okay, so that's arctangent. Okay, so we can look at arcsine. I picked number 50 next. F of x equals arcsine of x plus arccosine of x. The derivative rule of arcsine x is u prime over the square root of 1 minus u squared. Right? And again, u is what's inside the function. Now, arccosine is interesting because it has the exact same rule as arcsine. Right? It's this same rule, but it's going to be negative u prime. Similarly, up with this top one that we just did, if this had been arccotangent, it would have the same rule as arctangent, but with a negative u prime, if it was arccotangent. Okay, so we have our function here, ready to go. Derivative. So my u prime first, derivative of x is 1 over square root of 1 minus my u squared. Okay, arccosine, same rule, but negative. So we have negative u prime, derivative of x is 1, over square root of 1 minus my u squared. And what's interesting about that is because they have a common denominator, we can combine them. Well, 1 plus negative 1 is just 0. Okay, one more to demonstrate these. We have number 52. Y equals the natural log of t squared plus 4 minus 1/2 arctangent of t over 2. Okay, derivative. Natural log, remember, is u prime over u. So we have u prime, which is 2t, derivative of 4 is 0, over my u. 1/2 is just a coefficient. It'll just hang out. Derivative of arctangent is u prime, so 1/2 over 1 plus u squared. Yeah. And then before I do anything else to this function, I'm going to go ahead and clean up this second term here. The first term looks pretty nice, but this second term kind of has a lot of pieces to it. So we're going to do some algebra just so we can see what we're working with. And leave this 1/2 out here for a bit. Okay, you can kind of choose whatever you want first. I'm going to choose to get rid of that squared, those parentheses, right? So t over 2 quantity squared is the same thing as t squared over 4. Right, and again, there's a couple of different different next steps you could take here. I'm going to choose to get rid of that denominator by multiplying it by 4. But if I do it to 1, I have to do it to all 3. Okay. So we have dy dx equals 2t over t squared plus 4 minus, leaving that 1/2 out here. 1/2 times 4 is just 2 over 4 plus t squared in the bottom there. 4 times 1 is 4. The 4 is canceled, leaving us with just t squared. And then I see here that the 1/2 and the 2 could cross simplify, leaving me with 2t over t squared plus 4 minus just 1 now over 4 plus t squared. Okay. Okay, as I now look at the 2t over t squared plus 4 minus 1 over 4 plus t squared, I'm thinking common denominators, and in fact, these actually already are a common denominator, right? If I wanted to, I could just flip these two terms, make this t squared plus 4, right? And it would be the same denominator. So these actually already are common denominators, and so I can just combine them. We have our 2t, and then minus 1. You do want to make sure you're always careful with that negative, right? If there had been more than one term in this numerator over here, I'd need to make sure that minus got distributed to every term. In this case, there's only one term, so it's not really anything to worry too much about, but it is something to be aware of within the context of these problems in general. And there's our answer.